Okay, so this demonstration will be about the 3M game and the connection to reality. So we can imagine a situation where we have a customer and a supplier. And this is the simplest case of a customer-supplier relationship. In reality, we can of course have many customer and supplier situation in chains or even in parallel flows. But this is enough to demonstrate the principle that this exercise aims to address. So the customer will be the one who has some sort of need, and we usually call this need load or demand, and this can be a need for a physical product or a service, and usually we have some variation in demand over time. So in this exercise we will simulate this with a dice, so this will represent variation over time. And if we combine more than one dice throw, then we know that the distribution over time will be a normal distribution like this. On the other hand, we have the supplier, and this will be the one satisfying the customer need. And the supplier will have some kind of machine or transforming resource. So this can be a physical machine like a mill or a turning machine, but it may also be a service technician or a doctor or a surgeon and an operating theater and so on, but some kind of transforming resource. And this transforming resource have some kind of capacity. And this capacity will also have some variation over time due to downtime or sick leave, or just the fact that different tasks take different amount of time. And in this case we simulate it with a dice throw, but we also have some extra capacities to start with in round 1. And in the same way that the demand is normally distributed, the capacity will also be normally distributed. Then we also usually have some kind of stock of raw material, like this. And this stock can be a stock at the supplier with physical products. We can also view this as a subcontractor or the previous process step. Or if we think of an emergency room at the hospital, this would be people potentially seeking treatment at an emergency room. But we simulate it in this case as a stock of physical products at the supplier. Due to the fact that we have limited capacity in our transforming resource, there might form a queue in front of the transforming resource. So this may be just a conveyor of parts to process, or it can be the waiting room at a hospital. Okay, so this exercise aims to address the question, does the balance between load and capacity, does this influence the queue to the transforming resource? And if so, how does it influence this queue? How does the balance of load and capacity influence the queue to the transforming resource? And for the exercise we have we have a sheet for the different rounds. So we start with larger capacity than the load, and then the capacity is gradually reduced. So in round 4 it's balanced with the load, so we have the same load as capacity. So if we start with round 1, we can imagine that, okay, so the customer will want some products. So let's see how many products the customer would want. So the customer wants 5 products. So from the stock we collect 5 products like this, and we place them in the queue. And then let's see what's our capacity this turn. So we roll 4 and add 3, so we get a total capacity of 7. So we can produce 7 products. So let's see what happens. So we can imagine that we take a product from the queue and put it in the transforming resource, and then of course some kind of activity happens here. It could be a machining or some sort of treatment, but some kind of activity. So this is now finished, so that's 1 and 2, 3, 4, 5. Okay, so we have produced 5 and we were able to produce 7. In this case, in this exercise, we don't overproduce, and in reality this can be due to economic factors, that it's simply too expensive to use spare capacity to overproduce. But if we look at if we think of this as being the emergency room at the hospital, there simply are no more patients to treat. We have treated everyone. So in practice it's not uncommon that overcapacity is in some sense wasted, so we can't use it to make any more products. Okay, so if we look at the first round here, so we look at the queue and we can see that there are no products in the queue, so this would be 0 like this. So let's continue and go to next turn, and I will force the dices a bit this time. So we can imagine that we roll for the customer and it turns out that the customer wants 6. So we go to the stock and we collect 6 of the products like this. So we have 6 products in the queue like this. 6 products in the queue like this. Okay, and then we see what is the capacity for this this turn, and let's imagine we roll and it comes out 1. Okay, so we will be able to produce 4 of these parts. Okay, so let's see what happens. Let's remove these already delivered products and let's see what happens. So we take 1 and we do some sort of activity to this product like this. 2, 3, 4. Okay, so now we can see that we could only deliver 4 out of 6 that was requested. So we will end up with 2 pieces remaining in the queue. So if we take a look at this sheet now, then we would write 2 remaining in the queue. And let's go one round further, and let's repeat this. So we get a load of 6, so the need is for 6 products. So let's get them out of the stock like this. So let's add 6 to the 2 that was remaining. So we would get 8 in the queue. And then let's see what the capacity for this round is. And let's imagine that the roll is again 1. So we will be able to produce 4 this round also. So let's see how it goes. We take 1. And let's remove these ones, which was already delivered. 2, 3, 4. So we could deliver 4, that was our capacity. So if we look at the queue now, it will be 4 in total in the queue. So let's write 4 for turn 3, that's the total remaining in the queue. And let's roll the dice one more time, and I'll force the dice again. So we can imagine that we get 3 as a demand, and so we get 3 of these products and place them in the queue. And then let's imagine that the capacity for this day is also, we roll 3, but then we add 3 to this, so the capacity is 6. So let's see what happens. So these have already been delivered. So let's do 6 like this. 1, 2, 3, 4, 5, 6. Okay, so we have one remaining in the queue now. So we take this 1 remaining and put it in the queue for this turn. Okay, and let's do it one more time, and let's imagine the same dice roll. So the demand is yet again 3, so we take 3 and add it to the queue like this. And let's imagine that this is again 3, so we can produce 6. So let's see what happens. We get 1, 2, 3, 4, like this. And now the queue is empty. We had capacity for 2 more, but we won't produce them for the same reasons we didn't produce them in the first round. It might be too expensive, or physically not possible to treat patients, which doesn't exist. So this, if we look at the queue now, it's 0. So the queue can never go to negative. And again, the main purpose of the exercise is to see what happens if we complete the entire first round. What is the total in the queue, and what would be the average in the queue, and how does this change, or does it change when we reduce capacity? So that's the main point of the exercise, to see the balance between load and capacity and its effect on queue.